in order to move from this single element to a collection of elements, you actually have to know a little bit about transformations and continuity. This is really something that is based upon symmetry and how symmetry relates to creating chains. Now, there are four primary types of symmetry on a two-dimensional plane. They're translation, rotation, glide reflection, and reflection. So here in the translation, you can see that the single element is translated or moved exactly 1 unit over, okay, in one axis, yielding now 2. In the case of rotation, you can see in the top left corner, you have a design element, which is arrayed polar, right, or rotated 4 times in total, in order to fill a space. With glide reflection, you can see that you have an element which is moved over in one axis 1 step, and in another axis a half step, ensuring that there's continuity that occurs across the scene. And in reflection, you can see that the element, in order to be able to be continuous in that one direction, it actually has to mirror, right, or reflect about an axis, and then it can continue to reflect to fill a plane. So when we look at the case of translation, you can see that the design motif is just repeated in a straight line without overlap. So your simple design element, when translated, right, it actually forms a much more complex aggregation. So let's take a look at that. I'm going to go over here, and again, I always like to make copies, so I'll just come over here and make another copy. That way I have my original right here, and then I have, for instance, the new collection of elements will be over here. Now, since I have this element right here isolated now, I'm going to take my boundary and just copy that over as well. The reason for this is because it gives me a nice way to snap and ensure that things are being connected properly. Now, in Rhino, right, you can do this in a lot of ways. You could say copy and just copy, right? Remember, it's in one direction, precisely the same amount, right? Or if I go in the opposite direction, on the opposite axis, right, I can see here. So take a second and take a look at how to begin to chain your component using copy. Make sure that you're snapping accordingly, and I like to use that border again to ensure that I am snapping. My object snaps to end will ensure that it is in fact snapping over. Remember, if you have any questions at all, feel free to post the question to the questions box, and we'll take a look. I had a question, a really great question, about the backface color. If you notice that right here, my design element has one color on one side and another color on the other. And what that's indicating here is that the back faces are down because they are this kind of pink color. You can tell that this is the standard color of the mesh because of my layer color right here. In the layer tab, if you right-click, there is an option right here where you can open up display. With display open, and right now I'm in shaded view, you have options for how to set the background. You have options for flat shading, vertex coloring, turning on shadows, And down here you have the option to turn on backface coloring. With the backface coloring, I can turn on this option and change, right, this to always display a particular color to me if it's the back face. Now I just picked something that I would never use in my Rhino layer structure, and I just use that as my back face. All right, so copy this guy over. And you'll see here that we have now a collection or a chain of elements. You also notice that depending upon which direction you fold it, right, you'll get a very different surface effect. So now that we have a 2D or two-dimensional motif, and we also have a three-dimensional motif, and we understand how this connects, right, through chaining, we can begin to start take a look at grid-based modeling and how the understanding of those two things will work with paneling tools and the way that the grids are set up using the component in Grasshopper. Now, one thing to keep in mind is that this issue of transformation, how this element connects, is totally dependent upon what your boundary is set to. So if you notice here, if this were my design element, oops, let me see if I can't just make a new face really quick. I'm just going to go over here and click so that I have this element here. So for instance, if I had something like this as a design element, and I modified my control points, you can see that just a regular transformation through translation, right, would not be sufficient for me to actually connect these. And so you'd have to use something like glide reflection, right, to be able to chain these together. So I just want to make sure that everyone is clear about that, you know, that depending upon what that boundary is, so in this case you can see that the boundary would be a diamond, right, that it will ultimately affect the performance of your components. Okay, so you can see here this would not be able to just work through simple translation.